Thank you for the invitation to this gathering. I just wanted to reiterate that my position in this is not representing either the National Research Council or either of the standing committees that are dealing with energy efficiency. I sit as a member of the Housing and Small Buildings, Part 9, National Building Code. I was a member of the task group, which was part of the Housing and Small Buildings, and the Standing Committee on Energy Efficiency that was actually responsible for developing the changes to 936, as requested by the CCBFC and as requested by the PDPAC, the Provincial Territorial Policy Advisory Council on Codes, asked for a further development of 936 to the point where it would actually go in something like the BC code had already done in steps. In 936, it's now called tiers, to develop enhanced energy efficiency requirements that would bring Canada to what's been defined, I guess, as net zero ready housing, residential housing by the year 2030. So that was the background of the rationale for working on further developments and enhancements to 936. So, so as it says here, this is a proposed changes. They have not been adopted yet by the building code. They are part of the material that has gone to the Canadian Commission on Building and Fire Codes for adoption, but they haven't been adopted yet. So the major thing is this tiered energy requirements. There are changes on air tightness, and there was a changes that brought 936 into alignment with the EnerGuide rating system, and there were performance updates for equipment like HVAC and service water heating. So it's basically those four different changes. They were done through a whole series of task group meetings and standing committee meetings to make these changes. And then they all went out to public review. All the proposed changes went out to public review, and all the comments, hundreds and hundreds of comments on the changes were reviewed by the standing committee and the task group. And maybe edits were made to some of them based on the comments from the public. So the tiered energy requirements, basically there's a performance path, and the PCF stands for proposed change form. And so this is one of the change forms that put through the wording for a tiered performance path. And it was the performance path, basically they developed tiers 1 to 5. And in those tiers, there were both overall energy performance requirements and envelope performance requirements. So the idea was not to try and shift all of the improved performance into mechanical systems. There was a need to develop envelope performance requirements at the same time. There was also a prescriptive path, because 936 has both a prescriptive and a performance path. In the prescriptive path, there were only the first 1 and 2 tiers were developed at this time. And to go up a tier, there is the expectation that you will do energy conservation measures, and you'll have to get a certain number of points that are attributed to different conservation measures. And those points you'll have to get a certain minimum number of points to advance up to a next tier. So we have here, starting down at the bottom, we have tier 1, which is the current 936. And so there's no overall energy improvement. Tier 2 would be a 5% envelope improvement and overall energy of 10%. So basically you have to get a minimum of 5% improvement in the, that was the way the performance path was. You have to get a 5% improvement in the building envelope, and overall you have to get a 10% improvement. So you could do more in the envelope if you want, and then do other things that will get you to the total of 10%. Tier 3, you have to have a 10% envelope, tier 4, 20% envelope improvement, and tier 5, 40% envelope improvement, and your overall energy improvements go up and double in every case except for overall energy in tier 5 is a 70% improvement in overall energy usage. There's also an allowance for smaller buildings. And so if you have a conditioned volume of equal to or less than 300 cubic meters. So this is important, it's cubic meters. A lot of people saw this and actually were making a mistake thinking it was square meters, but it's cubic meters. So you're deemed to have savings of up to 10% if you have a volume less than 300 cubic meters. So the tiered prescriptive path, tier 1, as I said, is basically going to be the 2020 NBC, and there's some minor updates to the 2012, 2015 NBC 936 requirements. Now, in Manitoba, we have a different 936 requirements than the NBC currently. So there's going to have to be some reconciliation in Manitoba between those improvements, because there are things in the Manitoba requirements that aren't in the National Building Code requirements. For example, HRVs. HRVs are not mandatory. You get points for HRVs. And so we have to reconcile them. Tier 2 requires a minimum of 10 energy conservation measure points. Tier 3 to 5 is reserved for the next code cycle work. So that's going to happen in this next code cycle beginning 2021 and to 2025. So for example, to get to tier 2, you need those 10 energy conservation measure points. For example, above ground walls, in our climate zone in Winnipeg, current Manitoba requirements for 936 are as RSI is 2.8, whereas the NBC requirement is 2.97. So Manitoba relaxed the above ground wall RSI requirements, and they made mandatory certain other things. So if we followed from the current NDC of 2.97, you can see 2.97 here. This is a table taken from the new proposed changes. 2.97, you basically wouldn't get any points because that's the minimum base case. If you upgrade it to 3.08, you get 2.1 points out of the necessary 10 points. If you went to 3.69, you get 6.7 points. So that's the process you can go through for virtually all of the different measures. So there's energy conservation measure points for fenestration and door improvements, for opaque building assemblies below grade or in contact with the ground, for improved air tightness levels. So you get different points for different measures. On the air tightness end, we started originally, the task group made air tightness testing mandatory, but the commission required us, the executive policy group required us to make air tightness measurement optional. And so there is both a path for doing no air tightness test and a path for doing an air tightness test to prove, and you get some benefits for doing it. At the time these code changes were being worked at, there was not even a valid CGSB standard for doing air tightness testing, but that was uh, reaffirmed in 2019. And so they set up standards for air tightness, air changes per hour at 50 pascals, normalized leakage area at 10 pascals, and normalized leakage ratio at 50 pascals. And so there's different metrics that you could use if you do an air tightness test. And these metrics and the levels used are going to be reviewed during the next code cycle. So for example, air tightness points, this is from the table in the chart, pardon me, in the code proposals. And if I was to look at Manitoba, I would say virtually most Manitoba houses would fall in 2 air changes an hour. And in our climate zone in Winnipeg, southern Manitoba, that would give us 4.6 points towards the 10 points required for achieving tier 2. If we got down to 1.5 air changes an hour at 50 pascals, you'd get 9.3 points. So air tightness gives you a lot of benefits here, a lot of energy conservation points. There are also points for ventilation systems, and this is going from a standard ventilation system without HRVs to one with HRVs or VRVs. But again, Manitoba already has that requirement. So there's going to be some reconciliation between what is in the new proposed changes and what is in Manitoba currently. There's points awarded for different improvements to surface water heating efficiency and building volume. For example, if you build a house with a volume less than 300 cubic meters, you get your 10 points. It's automatically into tier 2. And so the other things that we're looking at is that were changed in the code are alignment with the EnerGuide rating system, the performance path. The EnerGuide rating system is now used as a compliance path. Any other tool that meets ASHRAE 140 may be used as well. Alignment with the EnerGuide rating system parameters. So research done by EnerCan showed that occupancy in Canadian houses, water usage, lighting, other base loads has changed in the last 10 years. So all of those requirements are now specified in the EnerGuide rating system. Equipment performance, furnaces, for example, gas furnaces, there's these are all standards, the performance testing standards, and these are things that are going into the Canadian energy efficiency regulations. The biggest change for us in Manitoba, gas furnaces will have to go from 94% efficient in new houses to 95 and be equipped with a ECM or high efficiency constant torque motor. There's surface water heating improvements. These are all part of the national regulations for equipment efficiency. So those are the basic changes that are being proposed and have gone to the Canadian Commission on Building and Fire Codes, and they are going to deliberate and decide whether the suggested changes are going to be adopted into the next version of the code, which will be 2020 code or 2021 code. It's likely it's not going to come out till December or January of 2021 or January of 2022 at this stage. Everything has been delayed because of COVID. So that's it. Thank you very much.
So I'm going to deal more with the National Energy Code for Buildings, which is generally called more of a commercial style of building. Some Part 9 buildings need to flip over to NECB. But the one, and I sit on 936 with John and also on NECB and look after the building enclosure part. And they're, in my opinion, two different codes. So we talk a lot at the codes hearings about how we want to simplify things. We want to make it easier for buildings. We want to do a whole lot of slew of things. And if you take a look at the presentation that John went through, I think we're making it more complicated for the builders. And I think and we started the discussion in BC and NECB about the fact that it's getting harder and harder to be very prescriptive in codes. And a lot of the stuff we're moving to performance requirements, and then we're trying to figure out how do we express a performance requirement in a prescriptive way. And I know at one time we in a lot of codes, we still get into how many nails you put in a 2x4 at the end on the plate and so on. But we are getting into more and more complicated buildings, and we're going to have to look at easier ways of doing that. And this is all personal sort of opinions that I have on that. Now, the other key thing, and outside of 936, which deals with energy, but the balance of the National Building Code deals with health and safety issues. And so it's what is the minimum that you can build without going to jail, is the way some people look at it. And we get into a lot of discussions as proposals are made from you, the public, or you, the builder, or you, the designer. Anybody can make a code change proposal. We get into discussions about, well, is buildings falling down all over the place? How many people have been killed because of this issue, and so on and so forth. And I understand this is a minimum code, but we have to start looking at what the consumer thinks we're doing, which is protecting them. And the energy code does not necessarily protect them in some cases. And then I see the code going for requirements going way overboard. Let's say on the American side with NFPA 285 and what the New York City is doing for commercial buildings, they're not bringing into building science into their equation there. So at least in NECB, our objective now got to energy. That was something exciting to add to the code, because before we couldn't talk about it. And rather than being a minimum code, it's a maximum code, because we're no longer talking about what is the minimum amount of energy you have to use. We're talking about what are the minimum amount of energy that you can use. And we understand that every Canadian has a right to do what they want and spend what they want and so on. But we also have to take a look at it in the big picture of what is the outcomes of all the things that are doing there. And everybody benefits from energy efficient buildings. So in the NECB, we basically split it up into three major headings. One is the building envelope, the other is the lighting, the other is mechanical. And in lighting, we're getting pretty close to the existing technology. We've done all we can, or I shouldn't say we've done all we can, but we're getting into areas where we've covered a lot. LEDs are now in there and so on. And one of the things that we're starting to find out is it's people's behavior that is now having a bigger and bigger impact. Even in NBC, we don't consider plug loads, and yet look around at your house. You're going to have number of TVs plugged in, and you're going to have charging for cell phones and everything else all over the place. And so those plug loads, although we're having more efficient units, computers and phones and everything, we have to start, which does not include the code, how we use our buildings. And then the same thing with mechanical. John's covered some of the things on the what I would concern more on the residential side of things. And we have the same type of things on the commercial side, the chillers and the rooftop units and so on. And those are things that we can still improve. And we also have regulations in Canada that we can't import equipment that's below a certain number. And we're also trying to harmonize that so that the builders are not stuck with the regulation on one side and the building code on the other side. And that's not necessarily an easy thing to do. When we get into the NECB, we made some, I think, really important decisions at the start. We decided that the building code should not get into designing buildings. We shouldn't dictate to the builder that you have to do this, or the designer, you have to do this. We should allow for innovation. We should allow for new products. We should allow for new designs. And so the code itself should stay out of dictating how you build your buildings, how you design your buildings. And I think that's very, very important. And personally, I will always push for that. And then in some of the building codes we've had in the past, depending on the fuel, you would have to put more insulation in. And in Manitoba, going back to when I was extremely young in high school, if you had electric heated home, you had to put a whole much more insulation in than it was a oil or gas heated home. And in the NECB, we're fuel neutral. So when we do the costing and the energy savings, it's based on a weighted average of all fuels in all parts of Canada and so on. So we're trying to stay away from whether you use electricity or gas. Overall, in North America, there is a huge push for electrifications. In a couple of examples, in California, unless you're using the word electrification in your presentation or in your letter, whatever it is, you're not even going to get looked at because we're really moving there. City of Seattle has now dictated that as of April the 1st, you cannot use any gas heating in apartment buildings in the city. So whether we agree with it or we don't agree with it, that's where we're going, I believe, in North America. Manitoba is very poised to take advantage of that. We do have a renewable energy, and it's something that most of the, let's say, homes in cities and buildings are cities, so a lot of electricity goes into that. And I'm starting to hear something that we talked about in the 80s and so on, which was hydrogen. And we had a lot of people in those days pushing hydrogen as the next fuel that's out there. Now I'm seeing cars that will run on hydrogen when the byproduct is water. And we have a lot of turbines spinning at off-peak times that we could really simply turn that into hydrogen at really low cost and benefit everybody at Manitoba. That's outside the code. That's the personal requirement or personal opinion that I have. Obviously, it's colder when we get up north and warmer when we get down south, so we don't necessarily need the same amount of energy savings to be able to have high efficient buildings nearly net zero, whatever you want to call them. So we do split it off there. And I'm going to focus a lot on the building envelope. This is a slide from BC that I think is really good as far as how do we get to low energy buildings? And you have to design it right. And we can do so much in designing buildings and allowing heat through fenestrations when we want it. But it's in some cases in Winnipeg, we can overheat buildings because we have a lot of glazings and we don't have means of dealing with it. How we orient a building, it goes on and on. Again, a lot of those things are outside of what we can put in to the code because we can't, again, dictate how you shape your building, how you place your building, where do you place your building, all the rest of the things. So we have to take a very sort of even keel approach and trust the designer to come up with ways of really benefiting from low energy buildings. And I have a bias, there's no question, but I believe the building enclosure or the building envelope is the most important part of your building. And two reasons. One is our building enclosure is around for a long period of time. Look around Winnipeg. I'm down on McDermott downtown in the Market Square area. The building I'm in is over 100 years old. I fully expect that building to be here in another 100 years. And we got lots of homes that were built in the war times in the 40s and so on, and they're still in good shape. And I look at my own home, it was 20 years old when I moved into it. I've been here for 23 years. I do want to sell this home. I've got almost 50 years into it. I'm sure the guy that, or the person that buys from me wants it to last another 50 years as a minimum. And we got to quit talking about, lifespan of 10 years, 15 years, 25 years. We should be talking as a minimum for the building enclosure 100 years. Some cases we can change things, like we generally figure that we have to change our roofing every 15 to 20 years. Hot water tanks in residential homes used to be 15 years. Now you're good if you get 7 years out of them, and so on. So if we can't change it easily, then we should build the best that we can. And the other part that comes in with high efficient buildings is that as you build more and more efficient, your costs go up until you get to a certain point, and then your costs actually dropped. And we've seen this in part 3 of the NECB. As we've added more insulation and we got the costing for it, actually, as we added more energy efficiency parts, the cost actually dropped per square foot. And that's just in the fact that we're doing things right, and we can reduce the size of mechanical equipment and so on and so forth. When we get to the mechanical side of things, that's I mentioned already, but we're really getting into a lot of occupancy behavior. And so if you got a large commercial building these days, it's almost automatically controlled, where you know exactly what's happening in all parts of your buildings, and you can adjust for them depending on whether people are there or not there, whether it's a sunny day, a cloudy day, and so on and so forth. But that should be making up the minimum amount of energy that you need. And then finally, the whole idea of a low energy building is we can get to the point where we can supplement whatever energy that we need for plug loads and so on with wind energy, solar energy, batteries, whatever that we need to do that. That's where we need to go. We can argue about whether this is going to be 2030 or 2050, but for all the things that we need to do for Manitobans and for Canadians, we got to work towards that goal. Some of the key attributes for building enclosure, obviously insulation. And I'll show you some of the things where we're heading with insulation, but at some point we're going to get to the Law of Diminishing Returns, which is around RSI 7. If you take a look at it, we have arguments that we should have more insulation on the roof because of the night sky radiation and so on, and that's true. But we do need to do better. And the pushback we get on it, well, you know, we're going to have our walls thicker and so on and so forth. And that's true. But there's good benefits. Back in the 80s, I was a home builder here in Winnipeg, and all the houses I built were double offset walls, 2 rows of 2x4s and a 2x8 plate. And so we didn't understand air leakage in those days. But the first house that I built, which is 252 Glenway, the gas company came out and changed the gas meter 4 times because obviously it was broken. And those houses are still around and still operating very, very well. The worst house I ever built was on McIver Avenue, and I built a 24-inch wall. That was the biggest mistake. But if I built 8-inch walls, double offset walls, they worked very well. What I didn't understand in those days was the convection currents that you get in when you have 24-inch walls out there. Plus, the big thing is you lose so much space. We're having new insulation materials coming out, very high tech, microfibers, vacuum insulated panels, and then we got some good old fashioned, one of the latest standards we're working on is sheep's wool. We're also working on a standard for hemp fiber for insulation. So everybody's going to have a choice of what they want to do, but we're going to have to sort to look at how we do things better. Air tightness has been around forever. It was put in the NBC in 1990 because of moisture control. And that technology that was developed by the National Research Council now has spread across North America. The Americans have picked it up and are really running with it. We're behind where we started out with it. We're behind, and we're only starting to put whole building testing and things like that. And I'll show you that in the code. But we've always said in Canada and the National Research Council and CMHC would give us all these charts of 30 to 40% of our air leakage is energy costs, or is the air leakage, and we have to start doing a better job of that. We also have to realize and accept the benefits of that, you know, whether it's sound transmittance, whether it's pollutants, dust, pollen that we're keeping out. And the past chairman of the Air Barrier Association of America lives in San Antonio, Texas. He has a beach house. His beach house, which by the way is all completely covered with the air barrier because it's an air barrier manufacturer, suffered a hurricane direct on I have pictures of the areas around it, everything's smashed. Planes are overturned and so on. He did not lose a shingle on his house. And they had some porch with 4x4 posts holding the porch up. And the wind was so strong, it moved the bottom of those posts. Fortunately, not enough to cause the canopy to collapse, because then the whole house would have been gone. He was part of that, the storm that we heard where they had frost in Texas. His neighbors all had burst water pipes, which means they were below freezing all around him. His house, again, because air barriers all over the place. The lowest temperature he received in his house was 61 degrees Fahrenheit. So there's a lot of benefits when we talk about resiliencies and where we're going and how do we keep a building built for a longer period of time. The most efficient building is one you never have to build. That's the best for resilience. So we got to start looking that way. And then optimized glazing. You can do a fantastic amount of things. And the manufacturers here in Winnipeg led the charge for how we built really efficient windows, really forward-thinking windows and so on. We kind of lost that. I hope that we can get that back and we become sort of a center of excellence for our fenestration technology. The critical barriers that you need in all your buildings: water shedding, water resistive thermal barrier, air barriers, and vapor barriers. You can't ignore those. The one we overthink is vapor barriers. We're starting to realize that whether we have them or not is not necessarily the biggest concern that we have in the world. Out of all of them, the thermal barriers for your insulation and air leakage control. When I was in construction, I worked on houses in East Kildonan, where there was built at the time where there was absolutely no insulation in the walls, but we had lath and plaster on the inside and stucco on the outside. Their heating bills with not a shred of insulation was no greater than their neighbors with lots of insulation in the walls. And then thermal bridges is a big deal. We used to ignore them. In fact, 2% of your building could be a huge thermal bridge and you could ignore it. We're starting to realize that we can't ignore those things. And those are actually a major heat loss in commercial style of buildings, especially wood framed, wood steel structures and so on. And we have a new CSA standard coming out, Z5010, specifically designed to be referenced in the code that gives you all the requirements of how you properly model those. It was suggested by Morrison Hurstville at one of our meetings that if we properly calculated the thermal bridging or measured the thermal bridging in real time, what we think we're getting for a U value, it's double that. So it means that we're losing a tremendous amount of heat that we don't realize. And that actually gets into another issue. But here's an example. Again, this is from BC to show where you should be going. We did propose at one time just simply energy units that you can work from. And you can see that you can start out 100 kilowatt hours per square meter per year and go down to 35. These are all feasible today. They're passive house requirements, but passive house is being done there. And we have discussed this at NECB, is rather than even getting into how much insulation you have to put in the roof and the walls and what is the U value of the overall window and so on and so forth, why don't we get full design capabilities to the designer and just require that they meet a target? And that would allow new innovations, better innovations, all the rest of the things that could happen. Wasn't accepted. It's back on the table again for discussion, and we'll see where it goes. Now, when we get into the U values of walls, roofs, and floors, this is actually from the 2015 code. And what we have actually done is just moved everything over one. And then there was some misalignment in it that we fixed up so that there was a constant decrease in U values as you went up. And that was accepted without any major modifications that's out there. So that is proposed for 2020. Zone 4 would start out for walls of 0.278 and roofs and floors 183 and so on. We have enough space to do a little bit more here. It's excuse me, as I say, we're running into the law of diminishing returns. So at some point, it won't matter how much more insulation we put in walls. You're not going to really reduce any savings in BTUs, or getting down to, thousands of BTUs per year type of thing.
Laverne, we're just running a little bit long, so if you could just wrap it up, please. Thank you.
Okay.
Sorry.
We did the same thing with fenestrations. We got buy-in from the industry, so that's one of the things we could really improve. If you improve U value of something's very low, very high down to very low, you get a lot of return. A lot of discussion with the fenestration industry, but they did work with us in here. They want to work with us as where we need to be in 2030. It's really simple for them. They don't want to retool every couple of times. Same thing with doors. We've reduced them, talked to the industry, they're accepted. This we had pushed back, and this we have delayed, and this gets into window wall. And they gave us a whole bunch of reasons why we should keep big windows, because in Winnipeg, we're in there for so long and we need to look outside and so on and so forth. So this is for discussion, but this will not change for 2020. It'll be the same there. The big issue is we started off with mandatory whole building testing for commercial buildings in part 3. The Code Commission came back and says you can't make it mandatory, so now it's an option. It is the least expensive option. The other options is going to take a lot of time to do things and to confirm it there. Thermal bridging, as I talked about, a lot of things, really simple things that we can change. Advanced framing's been around for a long period of time. We've never made use of it, but that's probably one of the big nuts that we have to crack in the 2025-2030. We have a brand new standard for commercial buildings, E3158, done by the industry. That's going to give us, and we did a pilot program and a round robin of testers here in Winnipeg. So it was very interesting to work on that. And you can't just go by the materials. That's why whole building testing. Peanut butter does a really good air barrier, but got to wonder whether you want to use that in your building to make it airtight. That covers it. Air leakage is a big thing, both existing buildings and new. We have to talk about actual energy savings rather than calculated or paper energy savings. And we got to grow some of the industries that will help us get out there. Thank you for your time.